It's still a really hard problem to solve. It went from being impossible to just really, really hard. We're doing stuff at the bleeding edge of agents. We haven't met many people that are doing things like this. I see a world where essentially every company has like a hybrid workforce, and there's humans that are collaborating with AI agents. The most important thing is your velocity, right? How quickly can you iterate through the failure to get to kind of the promised land with this technology?
Hi, I'm Brett Gibson, and welcome to HiBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups.
In today's episode, we're sitting down with Asver, Parcha founder and CEO. AJ is a repeat founder who founded Scoopler, a real-time search engine that he later sold to Google. He's now running Parcha, a startup that's building AI agents that autonomously complete laborious tasks for knowledge workers.
The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them.
Hey AJ, how's it going? Thanks a lot for joining me today.
Thank you so much for having me on HiBit. I really appreciate being here.
People may not know it, but we were part of the same YC batch back in the summer of '08, so we've known each other quite a while.
Yeah, I feel like we're really aging us. Right? What is that, 15 years?
Yeah, last batch in Boston.
We need to do some kind of reunion soon, I think.
Yeah, and so exciting that we're working together again now that Parcha is an initialized company. So perhaps we could start off, you could tell us, what does Parcha do?
Yeah, so we are building AI agents that instantly automate operations and compliance. And what we do is we use your existing policies, procedures, and tools in order to do that. So if you think about a fintech company, behind every great fintech company or beautiful app that you might have seen to move money around, there is an army of operations people that are basically helping that fintech company scale. And they are doing everything from onboarding customers to doing risk checks on transactions to underwriting for credit cards. And all of that stuff requires a huge amount of manual workflows. And my co-founder and I, when we were at Brex, we led the platform team that basically was responsible for automating all of that work. And we found that there was this last mile of automation that you just couldn't do without human expertise and human judgment. But now with AI and where we are with language models today, we're able to actually take that technology and create AI agents that can now actually automate those manual reviews. So what used to take people hours to do can now be done by an AI agent instantly. And what's really cool is you can scale those AI agents infinitely up and down depending on the amount of volume you have of manual reviews you need to do. And so that's what we're building, and really excited that you guys could join us on the journey as one of our seed investors.
Awesome. There's a lot to unpack there because that sounds like you're doing a great deal. But perhaps we can set the stage. Where are you in the company life cycle? How big are you? How many people are currently working on this?
Yeah, so we just started in March. I kind of put the initial MVP together, hacked it together on top of LangChain, which is a pretty popular framework for building AI products on top of. It connects to LLMs like OpenAI. And then my co-founder left Brex to join me. That's when we raised our seed round. We raised pre-seed and then a seed kind of all together. We had our first hire who leads our design team. And that is actually someone you know really well, Brett. It's John, who was your co-founder during YC.
Yeah, it was really excited to hear he was joining up. Okay, so there's a lot to dive into. There's so many parts of AI agents that I imagine are hard and sort of interesting to dive into. I imagine people are pretty familiar with LLMs and specifically ChatGPT and how you interact with it. How does an agent relate to a large language model?
Yeah, that's a really good question. If you ever use ChatGPT and you've given it an instruction and then it hasn't provided maybe the best answer immediately, and then you've said, okay, now do this, and then do this, and then do this. That is what we call chain of thought reasoning in large language models. And what it basically is the ability for a language model to generate tokens based on a broken down kind of plan of how to solve a problem. So you might give an AI language model the task of like summarize this document. That's like a very simple task. But if you break it down in chain of thought, you might say, first summarize the first paragraph and then write what some of the highlights are of that paragraph. then use that to decide what might be relatively important in the next paragraphs, and then highlight those two. That's chain of thought. And so some really cool engineers realized as they were playing with LLMs in the space, and actually a famous VC who turned like engineer using GPT-4 realized, was that you could take that process and essentially use it to get an LLM through multiple loops to carry out a task using a plan. So you say to the LLM, help me find a venue for my birthday party. It has to be in San Francisco. It's 21 and over. I'm really into sports. So it's got to be kind of a sports bar vibe. And so then this agent, what it would do is it would go take that objective and come up with a plan. And then you take that plan, put it back into the LLM and say, okay, now carry out the first step. And the next step, what did you learn after each step? And how do you carry out the next step after that? And that was really the dawn of what we call AI agents and using this chain of thought technology. And we're taking that technology and we're applying it to procedures that already exist inside companies. So for example, when you're onboarding a customer onto a B2B product, you might want to work out, okay, are they registered in Delaware? Is their business active right now? Is their tax ID registered with the state? All of those steps are kind of step-by-step pieces that normally a human would have to do. But using these AI agents, we can actually carry out the same thing. And the magic of how we do it is we take those same procedures that a human is using today, usually a Google Doc or maybe a wiki or somewhere in Confluence, and it could be like 10, 20, 30 procedures. And we give that to the agent and the agent executes on the plan. And what's interesting about that is we actually skip that step where the agent has to make up the plan itself, which makes it much more controllable and steerable in order to make these agents. And that's why we're really excited to apply AI agents in this space.
High-level insights are that AI agents, beyond just being able to generate text very well, are also able to do some level of logic and figure things out. So you come up with a list of things that it can assign you and or assign the rest of your program in some sort of procedural fashion. Ask it which of those are appropriate next for the task, and then interpret its response, and then go actually execute that in the real world. Is that like roughly the order of operations in terms of like gluing an LLM to an IO task that actually goes and changes something somewhere else on the internet?
Yeah, that's exactly it, actually. You pretty much pointed it out, exactly how the process happens. You have an agent, it gets given a plan, and then it works out what tools to use in order to execute that plan. And those tools are provided as like a set of specifications that the agent gets in the prompt. So the agent might be told in the prompt, think about how you use ChatGPT and you give it a prompt, right? You type in, might be told, you have access to this tool that can verify addresses. You have access to this other tool that can read state registration documents. You have access to another tool that can look at a business owner and verify their identification. And the agent will work out, for this step, and this step, I need those tools. And in its response, it'll say, execute tool Y or execute tool Z. That then connects back into our integrations. And now we're back into regular programming land where we're just executing functions against integrations that might be the same integrations that our customers use today to carry out those tasks manually.
Okay. All right. I think there's probably a lot of topics about why this is actually hard to glue together and get working. Just like off the bat, we all know that LLMs do and say crazy things sometimes. If you give it access to the outside world, won't it do something insane? Like, how solved a problem is that in the start? And what should we be thinking about in terms of giving a system that lets an LLM affect the outside world guardrails?
Yeah, I mean, if you think about how agents evolved, around May of this year, agents really took off, especially in the AI kind of community. People started building agents, and the original idea was like, let's build an agent that can be your personal assistant, right? It can do anything for you, plan a party, as I mentioned earlier, or maybe help you answer your emails. And they were very open-ended problems. And the challenge with that is these agents had to come up with a plan on their own and then execute on that plan. And sometimes they get stuck in loops because there's no way of really verifying if they got to the answer. What we realized and where we connected the dots is because our customers already have a set of plans that they use for humans today, that, when we give it to the agent, makes it much more steerable. The agent now is given a plan and it's really responsible for executing on that plan and then using judgment to make decisions at each step. So for example, the agent might work out, okay, this is the name of the business owner on their state registration document and this is the name on the ID. Maybe they're slightly different because one includes a middle name and one doesn't. But is that the same person? That's something an LLM can actually work out reasonably well. And so it's carrying out the plan in a pretty predictable way, but it's using judgment based on kind of the prompt engineering we give it in order to decide if we should onboard this customer or not. And that really helps narrow down the problem space and makes it much more straightforward to steer these agents. But there was another big advancement that also helped, and that was GPT-3 versus GPT-4. GPT-3 or GPT 3.5 was fast, but it wasn't that steerable. GPT-4 was much more steerable, which allowed this type of agent behavior. We actually don't use either. We use Claude, which is by Anthropic. It's a company that's an offshoot of some of the original GPT-3 engineers who wrote the paper. And what we found is that it's fast and steerable, which is really important for agent work. You want it to be fast because every step that it's thinking about, you want it to act pretty quickly, but it needs to be able to follow the instructions really well. So I think it's been a combination for us of one, having these like well set plans, and then also advancements in AI and in LLMs that have really helped get us to where we are today. But it's still a really hard problem to solve. It went from being impossible to just really, really hard.
So, all right, it feels like there's two high-level buckets. Like there's actually interacting with LLMs, getting to do and say what you want. And then there's connecting what you get out of them to real-world processes. Like when you think about what has caused you the most frustration in getting an agent to work end for end, where have most of your cycles gone?
Yeah, I mean, if you think about those two problems, right? The first one, trying to get an LLM to do the thing you want to do, is hard because we're all learning how to do it for the first time. Like we're all just new to this. So like I often feel like we're at the bleeding edge, just in what we're doing, of trying to get an LLM to do the thing we want it to do. So that's hard for that reason. And then integrating it with all of the integrations that a customer has is hard because it's just a schlep, as you say in YC, right? It just takes time to build all those integrations. That one has mostly execution risk because it's just, can you build the integrations fast enough to help with the customers? The former one is hard because it requires a lot of understanding and nuance and learning how to work with LLMs. It's kind of an art form in some ways. And to solve that, we've just spent a lot of time just building and prototyping and iterating and understanding what LLMs are capable of, what they're good at, sometimes shouting at them in all caps. And then once we work out how to do it, we like stop the all caps because we don't want the AI to get mad at us like later down the line.
Yeah.
But yeah, a lot of it is just kind of learning how to essentially manipulate this new technology, which as you mentioned earlier is like probabilistic, right? It's not deterministic.
Well, it's funny because you joke, but all caps, I assume, changes the output, right? Like anything you do is going to change the probability of the next token to come. So on some level, shouting at it like is perhaps what solves some problems?
It does in a way, although I prefer a different technique. Andre Karpathy talked about it in a recent lecture that he did, where he talked about how you can basically set the context for the LLM, and that improves the likelihood statistically that it's going to do a good job. So you can say to the LLM, you are an expert at onboarding B2B customers on a fintech platform. You are really good at making compliance-related decisions and answering questions about complex compliance policies. And by putting that in at the beginning, it actually increases the IQ of the LLM, which is kind of like crazy to think about, right? Why does that even work? But it does. It actually anecdotally, based on the evidence we've seen, it works pretty well. And that's like a common trick or technique to get an LLM to do what you want. It's just tell it should be smarter.
It's totally insane. Because if you think about how LLMs are trained, it's like all the text of the world. And it's not like we go around telling the smartest people we know before we ask them questions how smart they are. So it's really fascinating that it works that way. Is there a particular moment or problem that like we can zoom in on that like illustrates how frustrating, but how interesting these can be to deal with?
Yeah, I mean, I think the hardest one that we've had to deal with is just going from demo or proof of concept to like production grade LLMs that work in an enterprise. That just takes a lot of time and patience and understanding, and often it feels like a bit of whack-a-mole too, to get it right. For example, our first demo, we demoed a fairly simple 8-step process for onboarding a customer. It had like maybe 1 or 2 integrations. And we would show that to customers and they'd be really excited. They'd never seen anything like this before, right? Agent that's automatically onboarding a customer. But the reality is when we talked to customers and we looked at their procedures, or what we called SOPs, standard operating procedures, they were much more complex. They had like much more pieces, they had much more nuances, they were much more edge cases. And so we had to work out how to get from the POC we had or the demo we had to building something that could work for them in production. That was really hard. It took a lot of time. And certainly there were many things we learned in that process.
So was it like your first versions didn't anticipate like how complex a decision tree humans are actually working through, or was it just there was weirdness and edge cases in productionizing the workload?
Yeah, I mean, one of the challenges is when you look at how LLMs work, the more you add to the context window, you kind of reach this maxima almost, local maxima of like how much value it adds. Like what I mentioned earlier, right? Telling it's a genius at this area. That can work really well. But once you start getting to like 2,000 or 3,000 tokens where you've described like every possible scenario that an LLM could do and all the different steps it can take, it starts getting a little bit confused and it is not that good at doing its job. And you start seeing it kind of wander off or like not provide the right answer, often hallucinating, right? Which in our case is like the worst thing that can happen because that's essentially failing open for like a high risk compliance scenario where you don't want that to happen. So a lot of time at the beginning was spent just understanding how to destruct the agent into lots of components that were each much simpler that we could bring back together into a singular, more complex product. And when you think about that, it's pretty straightforward engineering, right? It's like not that different from what you would do in any other complex engineering task. You break it down, you kind of divide and conquer, build it into modules, and then put it back together. And that's essentially what we started doing. We realized that instead of having one agent that could go and solve this SOP, we would have 5 agents that would solve small parts of it. And then we'd have a supervisor agent that would basically instruct those agents to go and do each piece. And then it would take the pieces when it's brought back together and then make a final kind of recommendation to the user. That worked a lot better. But there were challenges even building that infrastructure too.
Did you literally tell the supervisor that it was in charge of other agents?
Really good question. So a common framework for agents is you have essentially agents and tools. So the agents have access to tools and they can use those tools, which are basically text in, text out in order to get to an answer, right? And the tool might say like, go look up on Google the website for this company. Or maybe it's like, go look up the ID of this person, this individual. And what we realized is we could basically take our micro agents, our mini agents, we call them worker agents. We could turn them into tools. And so the supervisor just sees a bunch of tools that it has access to, which are text in and text out. But actually what they are is like these more complex agents that then have access to their own tools. And before you know it, it's agents all the way down. And it might seem kind of crazy to think about, but it actually scales reasonably well because now you can scale to any level of complexity of tasks. And when we started talking to people in the ecosystem that build frameworks like LangChain or Llama Index, they were like, I don't think anyone else is doing that right now. And that was pretty cool to know that like we're doing stuff at the bleeding edge of agents. We haven't met many people that are doing things like this. And we certainly are excited about the fact that we're both solving real world problems, but also getting to kind of experiment on the cutting edge of what's possible with this technology.
Yeah, that's fascinating. Well, because it's like, in part, like if you squint at it, it's kind of like abstraction layers in software, right? Like up and down the stack.
Yeah.
But then each individual abstraction layer is not just like a function that has like some specific IO contract. It's like this automated thing of its own, right? Which brings me to my question. You're adding agents on top of agents all the way down. All of them have this interesting relationship with consistency and accuracy. What gives you confidence at the other end that the system's going to do what you want it to do every single time?
A lot of it is just simplifying the code base a ton. That was like the first step. So when we started building our agents, we, like many other startups, started on top of LangChain. LangChain is like an amazing framework to just get going and build a demo. But we realized that there were so many abstraction layers in LangChain for agent building, which, by the way, it's kind of amazing that agents came out and they built like abstraction layers for agent building in like a week or two. I'm just constantly amazed by how quickly that team moves. But the abstraction layers, which allow many different teams to build many different things, also makes it very hard for you to reason about the code for a particular thing once you get beyond demo and you start looking into production. And so the first thing we did is we just rewrote a whole agent code base. My co-founder Miguel like spent essentially a weekend just like hacking away at it, and he got it down to 500 lines of code. And what that meant was we could really easily reason about what was happening in the system. Now, we didn't have all these abstraction layers. Whenever there was a bug, we could quickly identify in 500 lines of code what was going on. We still use LangChain for a lot of our interface with the LLMs because it makes it very interoperable. We can swap a GPT-4 out for a Claude, and their tooling infrastructure is really great. But specifically for the agent, we did that first. So that was the first step. And then the second step has been like the schlep, really, which is you go talk to customers, you really deeply understand their use cases. You kind of shadow them as they do them. And then you go in and you try and solve those use cases and you start just like whack-a-mole. While that may seem like not the most efficient thing to do, I actually think it's the best way because basically your ability to iterate quickly on the whack-a-mole of like, okay, we solved this, and we solved this. Every time you do that, you're doing a learning step, right? You as a company, kind of as a collective brain that's building on top of this technology is learning more and more about how to use the technology. And so we've just spent a lot of time going deep with a small set of customers, building these agents and trying to get them to the point where they are production ready and they can start testing them. We backtest with their data. Once we get to 90% accuracy based on backtesting data, we give it to them, put it in their hands, and they'll find a bunch more bugs and stuff like that. And then we work out how to solve those too.
laddering up like this internal sensibility about how to fix things is pretty interesting, because it sounds like even the concept of bug is a little strange in this world, right? Like it's not like how, because like how often is it like, oh, I see this bug, I realize what's happening with the rigging, and how often is it like, oh, the LLM just not doing what we want in this case, and now we have to have another approach telling it what to do.
Yeah, often it's the latter. But one of the things we've started to realize as we do this is that the best way to really solve this at scale is to almost let our customers be the ones who learn how to do this. We're going to be able to do it to like maybe that 90% accuracy, but to get to 99% accuracy, we actually want to put it in the hands of our customers and let them be the prompt engineers. And it's funny because what our customers today are doing when they're training a human team to carry out these procedures is essentially prompt engineering, right? They create these documents, they give it to humans, the humans learn how to do those, and then the documents change, and then they have to retrain the humans. And so bit by bit, you have this institutional knowledge, essentially, which is your neural network, right? Which is running these procedures. And so what we try to do with our product is we want to get as quickly as possible to an editable agent that our customers can edit and start experimenting with and change and get to be more accurate. So they feel much more empowered to solve the problems. And at the same time, we're always raising the underlying tide, if it makes sense, by making the core technology of the agent better and better, constantly improving it. I mean, one simple example is we got the agents to generate a plan, right? So we would give them the set of procedures, but then based on that, it would write out a list as a plan. And originally that list was just a comma-separated list, but we found that the list works a lot better when you ask it to create a JSON list and then ask it to explicitly say what step it is, what step it's at on that list. Because now you're basically giving the agent more context in order to decide what to do next. So little things like that you learn as you go, improve the system, and you're kind of raising the tide. And then on top of that, we want our customers to have the ability to customize and continue to tune the agents too. And a big part of that will be benchmarking and creating benchmarking tools for our customers.
That's actually something I haven't really thought about, and it's really fascinating because it sounds like on the one hand, you have these intelligent things spread throughout the machine that have their own mind in certain ways, but also that means that the finished product has this additional layer of tunability and flexibility that can bleed through to the end user in a way that on a procedural code base, if a user finds an edge case, you kind of fallen off a cliff. It just doesn't work, right? Like there's not a fix for that. It could be an entire re-architecture of the entire system, depending on how poorly it was thought through, how poorly that need was anticipated. But it sounds like the flip side of it kind of having its own mind at times is that there's flexibility in the end. Is that true at all?
Yeah, I mean, I actually have this theory that one of the reasons so many engineers are excited to work on top of LLMs is that you get that dopamine hit of when it does the thing you want it to do, but it doesn't always. Right? If you think about that, that's like a pretty standard way of giving humans a dopamine hit. It's like you try a thing, it doesn't quite work, and then you change a few things, and then boom, it does the thing you want it to do. And I feel like that's almost like the future of how we're going to be writing code. Is like we're not going to be in these like very well-defined structured systems where like someone has to go in and change procedural code, change conditional arguments. We're going to be in this place where like essentially people will get good at understanding and manipulating these agents to do the thing you want it to do. And the operations folks today that are running these manual reviews will essentially become prompt engineers. And they'll be really good at essentially manipulating these agents in order to get the outcome they want out of it. And the cool thing about that is that it's in their hands, right? They have the ability to do it. And the other awesome thing about it is like it's a real-time response, right? Like think about when you're trying to roll out a new procedure for underwriting. It will probably take a month for that to circle down to the whole team, for it to be changed in all your policies, and then your engineering team needs to go change it in the code, your internal tools need to change, maybe machine learning model needs to be retrained. Now it's just an operations person. He's like, okay, what I want you to do instead is only let the customer have this much credit if they meet this threshold. And you say that to the agent and you can start running it. And the cool thing about our agents is you can just run like 100 of these in the cloud and just see what the output is on backtesting data, right? Like they can just run in parallel.
Yeah, that's fascinating. Like as a society, we build up fluency around interacting with agents and LLMs, and as they pervade everywhere, we end up with much more sort of flexible and adaptable systems. And by the way, the dopamine hit is actually like, I read about like psych experiments where if you give a rat a button and if it gets a treat every 10 times, it just hangs out till it's hungry and then it hits it 10 times. But if it's a variable number between 1 and 10, it just like, it's like constant. Like the variable reward systems like really hack mammalian brains.
They do, yeah. And then the challenge is like, how do you turn that variable reward system into like a deterministic system when you're running compliance, right? Which is like not something you want to be like probabilistic. And
is it scary for your customers ever then? How are they reacting to the idea of agents? Or are people like, oh, they're like...
I think people are mostly surprised by the capabilities that exist when we show it to them. They're like, oh, I didn't even know you could do that with AI, right? And so that's like, as a founder, I personally just love that moment when I've shown someone something they didn't know was possible, and you see that their eyes kind of light up, and they're like, and then you can see that they're starting to think about all the different problems they can now solve with this tool they just didn't have before, right? And so that to me is like such a motivation for me to build this and get it right. Our customers obviously always ask us, what about hallucinations? What about all these different things? And that's why with our first set of customers, we're just super hands-on. It's like a white glove experience. We're like, I often joke like these agents are hand-built in California because we're literally hand-building every single one. But we think that's the right way to approach this in the beginning, right? Because like when you're on the bleeding edge and you're trying to build these things that no one's done before, you kind of want to get it right first and understand all the nuances. And so we just spend a lot of time with our customers making sure we do really well. We release early, put it in a test environment. With one of our customers right now, we're doing that. They give us a bunch of feedback. They're still running it in a test environment, in a sandbox, not in production. And we iterate, we make improvements. They give us more data, they give us back testing data. And constantly in the back of my mind, I'm always thinking like, okay, what does it look like to scale this to 100 customers? What are we going to need to build, right, to make this into a platform? And so bit by bit, every week, we kind of pick away at that platform too, as we're trying to build the like point solution for our customers.
Even if there's some fear, like at the end of the day, if it works, and people kind of move on and are happy with the result. I got access to one of the AV programs in the city yesterday. I took one for the first time. For the first 2 minutes of the ride, I was like, oh my God, this is the craziest thing ever. And then I just started playing with my phone and hung out until I showed up where I needed to go. And then it was like normal.
Yeah, one of the most surprising things I would say is a piece of feedback we got from our customers is we give them the first version of our product as a Chrome extension. They can run it alongside their human kind of processes. Often an operator will run it. And it shows them exactly each step that the agent takes, why it's making those steps, and provides reasoning. And we built it that way because we're like, well, one, it makes it easier to demonstrate when we're demoing the product. But also, we want to build trust with our customers so they really trust this agent before they decide to like use it in an autonomous fashion. The number one request we get from everyone is like, when is this going to be available as an API endpoint that I can just send my customer manual reviews to and just get an output from? And we're like, well, hold on. We want to get there, but first let's make it really, really good for you, and then we're going to give you the API endpoint. But like that's a trivial problem to solve, right? Once you can make the agent really great. Yeah. But it's always surprising to me how quickly people are ready to embrace this technology.
Yeah, that's awesome. I guess stepping back, what have you learned about solving engineering problems from this process and trying to figure out how to get agents into production?
Yeah, I mean, I think for a start, it's been a really fulfilling experience for me because I've been in product for the last 10 years, but I come from an engineering background. When we did YC together, like we all coded, right? Yeah. And so going back to building again has been so great because I get to like go down to the metal and just like when customers have bugs, like, whoever is available will go fix it. And sometimes it's me. I think one of the things I've learned, first of all, is like just I forgot how much I love building again. But I think one of the other things I learned is when you're building with AI, your ability to think creatively and your ability to try different solutions and just move quickly and iterate is actually far more valuable than any academic experience you have. I think a testament to the fact that that's the case is that I spent like 6 months going deep into AI and then built a prototype of this with my co-founder. But we didn't have like a deep background in applied AI. Now, Miguel, my co-founder, led the data science team at Twitter and then also at Brex, but no one was using LLMs back then. It's all machine learning, right? It's a very different type of skill, but we learned how to do it. And a lot of it was just iteration and trying things and failing like multiple times. And so the most important thing is your velocity, right? How quickly can you iterate through the failure to get to kind of the promised land with this technology? I think that's what's exciting about it. It went from being impossible to just really hard. Yeah. And hard things can be solved with enough like resources and time and effort.
I mean, I think there's this baseline of like startup engineering where it's kind of like you embrace moving fast and figuring out how things go. And it sounds like you have to lean into that even more when you're dealing with these kinds of systems. Where do agents go from here? Like, I know that Parcha is going to be delivering a lot of value to your customers. Do you have like high level sensibilities about the next stages or phases we're going to see from the tech?
If I was to be a betting man and predict what was going to happen, I think we'll see a lot of progress in very verticalized agents like the ones we're building. And the reason for that is the problem is well constrained and defined, right? But it's still really hard. And from our own experience, if it's so hard to build an agent that is verticalized, I can't imagine how complex it would be to build a general purpose assistant. And so I think we're still ways out of doing that really well. I often wonder, like, will we solve AGI before like self-driving cars are proliferated everywhere, because maybe like that's the real problem we need to solve. It almost feels like, to some degree, to solve like general purpose agents, we need to get a bit closer to AGI in like a more practical sense. Whereas with these like more specific agents, the constraints help to manage it. I see a world maybe 3, 4, 5 years from now where essentially every company has like a hybrid workforce, and there's humans that are collaborating with digital employees, is what we call them. They're essentially AI agents that are assigned specific tasks and have ownership over specific areas that we would consider today to be kind of the drudgery of work, or like the busy work that needs to be done. And I believe what it's going to do is, one, free up humans to do more creative and strategic work, but it's also just going to create way more companies. I just think there's going to be more economic value created in the world. Like 1,000 times more companies can be created when like each one only needs like 5 people to run it to get to 100,000 customers, instead of 100 people to run it to get to 1 million customers, you know? And I think that we're going to see that play out in a lot of economic value created in the world, and abundance, right? I think like this idea of like abundance is going to be a really interesting one. I don't know what we're going to do with all this abundance. We might just have a lot of time on our hands. That to me is really exciting. And I also think there's an area of this as AGI kind of advances around kind of embodying these agents with more than just like rational logic, but more like emotions and like ability to kind of rationalize outside of the kind of more traditional kind of left brain thinking. And I think for that piece of it, there's some really cool stuff happening in the space right now where people are experimenting with like emotional agents, like AIs with souls and stuff like that. And I imagine some aspect of that will bleed into the enterprise workspace as well, because if you think beyond just like one workflow at a time and really think about how do you get an agent that can own an area of expertise, or like, you know, reasonably be responsible for like a part of a business, you kind of need a bit more nuance, a bit more emotional awareness. You need the ability for that agent to communicate with other agents, with other humans, more importantly, right? And to do that, you need empathy towards your human collaborator too. And so I think that's where we're going to see things going like 5 years from now. And that's where I think like digital employees could be really fascinating space, is not just having these like, you know, API requests, but like fully fledged embodied agents that are operating inside your business.
Yeah, that's all really interesting, because it does, and like, and the predictions around like when and how we get to AGI are fascinating too, because it kind of goes back to the core capabilities of the LLMs and the advancements there. And then, you know, for now, like the IO to the rest of the universe is like finite in terms of like the tasks you can give it. And those tasks can be pretty complex, as you've described, right? They can be a task that is an agent that does tasks. What's next for Parcha specifically then?
Yeah, for us, I think the next step is going beyond kind of our early design partners to building a scalable platform where anyone can come in as an enterprise and start spinning up agents themselves. It's probably going to need some sales-led approach at the beginning, but if we can move away from us kind of doing technical implementations to, let's say, a salesperson doing prompt engineering in order to get an agent to be in a good place for one of our customers, that I think is a huge leap forward. And of course, the dream in the end is that we can have more of a bottoms-up experience where you can come in, create one of these agents, add all the integrations you want in a pretty self-serve way, and start deploying these agents inside your company. And that's where we want to get to in the end, but it's going to take some time to get there.
Yeah, awesome. That sounds like a really exciting team with a really exciting future. So I look forward to all that. And I got to figure out where I need agents in my own workflows in my life. Looking forward to seeing what's next, and sounds like exciting opportunities at Parcha. So thanks a lot, AJ. This has been really fascinating and a lot of fun. So thanks for spending time with me.
Thanks for having me on the show. Appreciate it.
Highbit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heinz. And I'm Brett Gibson. Thanks for listening.